By the end of the lesson, you should be able to identify numbers that are divisible by 11. By the end of the lesson, you should be able to identify numbers that are divisible by 11. Learners, before we begin today's lesson, or we start, let's go through the homework to the previous lesson. Alright, we want to mark ourselves. The first one is when we add, we will get a number that is divisible by 9. We have this to be divisible by 9. This. This. And this. So look at it and assess yourself. If you have your sibling by you, just exchange your work and then mark it yourself. Alright. I hope you have done that and you had everything correct. Alright. That are divisible by 11. We are to identify numbers that are divisible by 11. Before we can do that, there is a rule we must follow, and that rule is divisibility rule of 11. And what does the rule say? It says a number is divisible by 11 if the difference between the sum of digits at odd places and even places is either 0 or divisible by 11. So we are going to look at the sum of digits at the odd places and the even places. If we check and the sum is either 0 or divisible by 11, it means that number is divisible by 11. For the rule, I'll give you a minute to copy it into your exercise book. Alright, learners, I believe you have it in your books. Now let's pick a question, a number, and then identify if that number is divisible by 11 or not. Okay, let's try this number and see. 413. Let's see if this number is divisible by 11. Let's look at the number at the odd and then even places. Before we can do that, let's position the numbers. This will be our first, second, and then third. So the number at the odd places, we have 3 and then 1. Let's add 3 and then 1 and see. When we add 3 and 1, we will get 4. And then the number at the even place, it's over here. That is the 4. So the difference, it means we must subtract. So minus the number at the even place. We have only 1. So we will write it. And 4 minus 4 will give us 0. Learners, it means the number 143 is divisible by 11. Why are we saying that? When we added the numbers or the digits at the odd places, we had 4. And the digits at the even place, it was 4. We subtracted it and then we had 0. The difference is 0. It means the number 143 is divisible by 11 per the rule that we read. Alright, another one. Okay. 956. 956. Let's check if this number is divisible by 11. Let's position the numbers. So we start from the right. We have the first one, second, and the third. Let's identify the numbers at the odd place. We have 6 and then 9. Let's add them. 6 plus 9 will give us 15. Let's write the 15. Now the number at the even place is 5. So 15 minus 5 will give us 11. And we know 11 is divisible by 11. Therefore, 900. Okay. When we add the number at the odd places, 9 and then 6, we will get 15. Now the number at the even place is 5. Let's subtract it. When we subtract 5 from 15, we will get 10. 15 minus 5 is 10. Is 10 divisible by 11? No. 10 is not divisible by 11. The rule says when the difference is either 0 or 11 or a number divisible by 11, it means that number is divisible by 11. But let's look at something here. This is the number 956. And we have to position the numbers. We have the 6 to be the first, 5 is second, and then 9 is third. So we have first, second, third. So the numbers at the odd place, we have 6 and then 9. Let's add 6 and 9. When we added, we had 15. The number at the even place is 5. Let's subtract 5 from 15 and then we will get 10. Let's check if 10 is divisible by 11. Can we divide 10 by 11 without any remainder? There will be a remainder. So 10 is not divisible by 11. Therefore, this number 956 is not divisible by 11 or multiple of 11. So learners, let's cross it. Let's look at another example. 395. 395. Is it divisible by 11? Let's position it and see. Let's order them. 1, first, second, and then third. The number at the odd place is 5 and then 3. When we add 5 and 3, we will get 8. The number at the odd place is 9. When we subtract 8 from 9, we will get 1. Is 1 divisible by 11? No, 1 is not divisible by 11. Therefore, 395 is not divisible by 11. Alright, another example. Let's try this. 2087. 2087. Let's see if it is divisible by 11. Let's position the numbers and see. This is first, second, third, and then fourth. We have to add all the numbers at the even places and then the numbers at the odd places. So let's identify all the numbers at the even places. We have 2 and then 8. When we add 2 and 8, we will get 10. We are looking at a difference, so it is minus. Let's check the numbers at the odd places. We have 1 and then 0. So when we add 0 to 7, we will get 7. And 10 minus 7 is 3. Is 3 divisible by 11? No, 3 is not divisible by 11. Therefore, 2087 is not divisible by 11. Let's try another one. 814. 814. Let's check if it is divisible by 11. As we've been doing, let's order the numbers. This is first, second, and then third. We're going to add all the numbers at the odd places. So we have 4 and then 8. 4 plus 8 is 12. Minus the number at the odd place. It is 1. And 12 minus 1 will give us 11. Learners, is 11 divisible by 11? Yes, 11 is divisible by 11. So, the number 814 is a multiple of 11 because when we added the digits at the odd places, we had 4 and then 8, which is 12. When we add 8 to 12, we'll get 8 to 4, it will be 12. The number at the even place is just 1, is 1. So 12 minus 1 will give us 11. And the rule says when the difference at the odd and the different place is either 0 or divisible, a number divisible by 11, it means that number is divisible by 11. We had 11, so 814 is divisible by 11. We can divide 814 by 11 and there will be no remainder. So let's check it. Let's look at another example. 208. Is it divisible by 11? Is 208 divisible by 11? Let's order the digits and see. We have first, second, and then third. So the number at the odd place, we have 8 and then 2. 8 plus 2 is 10. What is the digits at the odd place, at the even place? It is 0. So 10 minus 0 will give us 10. And is 10 divisible by 11? No, 10 is not divisible by 11. Therefore, 208 is not divisible by 11. We have 1947. 1947. We want to check if it is divisible by 11. Learners, let's order the digits and see. So here, this is first, this is second, this is third, and then we have fourth. We have ordered the digits. We have to add all the digits at the odd places and then the digits at the even places. Which one should we add first? Okay, let's add the digits at the odd places. We have 7 and then 9. 7 plus 9 is 16. So let's write it here. Minus, let's check the digits at the even places. We have 4 and then 1. So 1 plus 4 is 5. So when we subtract 5 from 16, we will get 11. Therefore, okay, let's check if 11 is divisible by 11. Yes. When we divide 11 by 11, there will be no remainder. Therefore, 1947 is divisible by 11. Okay, learners, I want you to try this for me. 2080. I want you to try your hands on this. Check if it is divisible by 11 or not. You have just 30 seconds to do that. Alright, your time is up. Let's do it together. First of all, we have to position the digits. We have this to be first, second, third, and then fourth. Let's add the digits at the odd places. We have 2 and then 8. When we add 2 to 8, we will get 10. Now, the digits are the odd places. 3 and then the digits are the odd places. We have 0 and then 0. 0 plus 0 is 0. So we subtract it from 10. And when we subtract 0 from 10, we will get 10. Is 10 divisible by 11? No, 10 is not divisible by 11. Therefore, 2080 is not divisible by 11. Let's try more examples. $957. You have just 30 seconds to do it. So we have to order the digits. So we have first, second, and then third. Let's add all the digits at the odd places. We have 9 and then 7. 9 plus 7 is 16. So let's write it here. We are looking for the difference. So the digits at the even place is 5. Let's write our 5. So 16 minus 5 is 11. Is 11 divisible by 11? Yes, 11 is divisible by 11. Therefore, 957 is divisible by 11. I hope you had it. That's good. Now let's look at our last example. we have 50,248. 50,248. Is this number divisible by 11, learners? Let's check and see. Let's order the digits. So we have our first, so this is first, this is second, we have third digit, fourth digit, and the fifth digit. Before we can do that, we have to order the digits. So we have first, second, third, fourth, and fifth. Alright, now we're going to add all the digits in the odd places. So what are they? We have 8, 2, and then 5. They are the digits at the odd places. So 5 plus 2 is 7. 7 plus 8 is 15. So let's write the 15 here. Minus, let's add all the digits at the even place. We have 4 and then 0. So 4 plus 0 is 4. Good. Now what is the difference? 15 minus 4 is 11. Is 11 divisible by 11? Yes, it is. Therefore, 50,248 is divisible by 11. I hope you are following. Should I go over? Alright, this is the number 50,248. We want to see if it is divisible by 11. Before we can do that, we have to are looking at 4 as 11. If the result is 0 or a number divisible by 11, then that number is divisible by 11. So this time we had 11, and we know 11 is divisible by 11. So 50,000 to number. Learners, this brings this is your task. Write 5 three-digit numbers that are divisible by 11. Write 5 three-digit numbers that are divisible by 11. It means you are going to write 5 numbers, and the numbers, the digits should be 3. I want 3-digit numbers that are divisible by 9. So the 3-digit numbers that are divisible by 9, you are going to write just 5 of them for me. So I will give you just a minute to copy your task into your exercise books. And it starts now. Learners, I believe you have it in your exercise book. Good. This brings us to today's lesson, and I hope you have enjoyed it.